Okay, changes in protein conformation or protein structure or protein shape can lead to aggregation, myeloid formation, plaque formation, holes. Then our brain organ becomes like sponge, SpongeBob. Yeah. So this is about a protein misfolding disease. Okay, this illustration I think is clearer than the text to show how PRP protein, prion protein, becomes infectious. At the beginning, PRPC or normal prion protein is functional, then is used by brain organ. However, when this normal prion protein or PRPC interacts with any PRPSC or scrappy prion protein, the normal one is converted to abnormal one. So this is what we call infection in TSE. It is due to the interaction between PRPC and PRPSC, leading to conversion of PRPC to PRPSC. At first, there is only one PRPSC or one scrappy prion protein. Now it becomes two scrappy prion proteins. And the same scrappy prion proteins can convert other normal scrappy protein to become abnormal ones. So it looks like a cycle of conversion, a cycle of infection caused by scrappy prion protein. Finally, all or 90% abnormal prion proteins, they are converted to PRPSC. So the higher level of PRPSC can lead to plaque formation, hole formation, and brain death, and others. Okay, we want to try to play the second short video here. Pun tak jadi Okay, again we need to skip this animation. Don't know the problem. Okay, we can summarize that TSE is about protein misfolding, related to protein misfolding. It's about the conversion of PRPC to PRPSC, and also it becomes more critical due to the plaque formation in brain organ, and this TSE disease can cause death. Okay, is that clear? Ada soalan tentang TSE?
Ada, Doktor.
Okay, sometimes in final examination or test, you are required to answer the question related to TSE. TSE disease development. I suggest you provide this kind of illustration. You provide this not flowchart, but yes, this image or illustration to show that how scrappy prion protein or PRPSC can convert normal PRPC to abnormal ones. It should look like a cycle, okay, where the normal prion proteins become abnormal and subsequently it convert the other abnormal prion protein. So it should look like this. Okay, moving on to the second problem related to abnormal protein structure. This disease is called Alzheimer disease, and I don't want to discuss further about common symptoms because this part of a chapter focus at molecular level. Okay. This disease involve a myeloid beta and tau protein. Okay. Uh, okay. We can see the same problem, namely protein aggregation of tau protein. Then it leads to hyperphosphorylation. Aggregation is due to hyperphosphorylation of tau protein. In cellular system, in living cells, phosphorylation may happen on three different amino residues, namely serine residue, threonine residue, and also tyrosine amino residue. So hyperphosphorylation on these amino residues, it can cause aggregation of tau protein. Oh, also not working. Okay, the last one is Parkinson disease. Type 2 is also shown here. Okay. Parkinson disease involves alpha synuclein protein. Okay. So the structure changed to beta sheet-like oligomer, and like other disease, it forms aggregate. And this aggregate can lead to formation of fibrils, which are commonly called Lewis bodies. So Lewis refers to scientists discovering this kind of abnormality of alpha synuclein protein. So from different stages here, for example, stage 1 until stage 6, we can see the abnormality due to Parkinson disease. Distribution of Lewis bodies, it happens in this part of brain organ. and subsequently, these Lewis bodies